Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi everyone. In this video, I will discuss the solution for Ujian Selaras 2 PHYSICS SP015 2023-2024 session. So in this video, we will discuss the question that relate to the topic oscillation of wave, physics of matters, kinetic theory of gases, and thermodynamics. For question number 6a, a body of mass 3 kg move in a simple harmonic motion. The displacement y from the equilibrium position at time t is given by y is equal to 5 sines 2 pi t, where y is in centimeter and t is in second. Referring to the question, first step as usual, when you read the question, please list all the information given from the question. And now, take a look at the question. First, question number 1, you need to determine the amplitude and period of the simple harmonic motion. So, referring to the equation of the simple harmonic motion, which is y is equal to 5 sines 2 pi t, we know that the amplitude is equal to 5 centimeter or 0.5 meter, 0.05 meter. And for the period, we know that the omega is 2 pi radian per second. For the period, t is equal to 2 pi over omega. And then you substitute the omega 2 pi, you will get that the period is 1 second. For question number 2, you need to calculate or determine the magnitude of maximum acceleration of the motion. For the maximum acceleration, we will use the equation of A max is equal to A omega square. A is 0.05 meter and omega is 2 pi, so A omega square. When you calculate, you will get that the maximum acceleration, the magnitude of the maximum acceleration is 1.97 meter per second minus 2. For question number 3, 6a3, you need to determine the kinetic and potential energy of the body at time t is equal to 5 seconds. Firstly, we need to determine the displacement when t is equal to 5 seconds. Because of that, you need to substitute the t inside the equation of simple harmonic motion displacement. And then your calculator mode is supposed to be radian. You will get that the displacement when t is equal to 5 seconds is 0. When you get the value for y, this displacement, you can calculate the kinetic energy, which is the simple harmonic motion kinetic energy is equal to half m omega square e square minus y square over y is equal to 0. Just substitute in the equation, and if you calculate, you will get that the kinetic energy is 0.15 joule. For the potential energy, we do the same thing. The equation for the potential energy is half m omega square y square. We substitute the y where y is equal to 0. Because of that, the potential energy of the body at time t is equal to 5 seconds is 0 joule. Question 6b. A progressive wave with a velocity of 100 meter per second, frequency 50 Hz, and amplitude 50 centimeter propagate from left to right. Write the equation for the wave. As usual, when you read the question, list all the information given. Here, there is hidden information where in the question stated that the wave propagate from left to right. So, hidden info is the sign that we will use in the equation is negative sign. Now, take a look at the general equation for the progressive wave, where y is equal to a sine omega t plus minus kx. To write down the equation for the progressive wave, you need to know the value for a, omega, and k, wave number. So, referring to the question, we know the amplitude, which is 0.5 meter or 50 centimeter. And then for the angular frequency omega, it is equal to 2 pi f. Our frequency is 50. Substitute in the equation and you get 100 pi radian per second. For the wave number k, when you want to calculate the k, you need to know the wavelength. So, we use the equation of v is equal to f lambda. Substitute the v and also the f, which is 50. So, we get that the wavelength is 2 meter, and we substitute in the equation of wave number k, we get that wave number is equal to pi per meter. When we get all the info, we substitute in the progressive wave equation. So, y is equal to 0.5 sine 100 pi t minus pi x. Don't forget to write down the unit because of our amplitude is in the meter. So, x and y is in meter and t is in second. Question 6c. A copper wire of mass 300 gram and length 3.5 meter has one of its ends fixed to a wall and the other end is forced to vibrate transversely with a frequency of 200 Hz. If the tension of the wire is 135 Newton, we need to calculate the speed and wavelength and also the number of harmonic. Firstly, this is all the information given from the question, and if you refer to this info, we have the M and L, so we can get the mass per unit length, the hidden info, which is mass per unit length, equal to 8.57 times 10 power of negative 2 kilogram per meter. And now to calculate the speed, we know that the speed in the wire is equal to T over mu, where T is the tension. Just substitute the value for tension and mass per unit length. You will get that the speed of progressive wave produced is 39.69 meter per second. To calculate the wavelength, we refer to the equation of V is equal to F lambda, and our V is 39.69. Our frequency is 200, so you will get that the wavelength is 0.2 meter. For question number 6C2, we need to calculate the number of harmonic for the stationary wave produced. Number of harmonic is represent N. And we know that this is a wire. So for wire, the frequency Fn is equal to Nv over 2L. And we substitute the frequency, we substitute the V, which is we have calculated 39.69. And also the length of the wire, 3.5. When you calculate, you will get that the N is 35.27. But we know that our N is integer, number of integer. Because of that, N is equal to 35. Question 6D. A train that has a 150 Hz horn is moving at 35 meter per second in still air on a day when the speed of sound is 340 meter per second. You need to calculate the frequencies observed by a stationary person at the side of the track as the train approaches and after it passes. So in this case, we will refer to the Doppler effect equation, so as shown. And our main point is we know that the observer is stationary, so V naught is 0. Vs is the speed of source, so 35 meter per second, and Fs is frequency of the source. But you need to identify plus minus sign. So to identify the plus minus sign, we will use the concept of OS. OS means that S is source, O is observer. If the source moving to the stationary observer, so the arrow is the yellow arrow, shows that we need to use the negative sign for the Vs. Okay, for the green line, for example, green arrow, if the observer moving to the stationary source, so we will use positive. So in this case, we will choose the negative sign for the Vs. Because of that, referring to the Doppler effect equation, we know that to calculate the apparent frequency heard by the observer when the source is approaching is V divided by V minus Vs times Fs. And when you substitute all the value, you will get the apparent frequency is equal to 167.21 Hz. And also we need to calculate the apparent frequency heard by the observer when the train passes the observer. So when the train passes observer, meaning that the source S moving away from the stationary observer, so the blue line to the right, a blue arrow here. So we will use the sign positive. Because of that, if you refer to this equation, the V divided by V plus Vs. And when you substitute the value, you will get the apparent frequency heard by the observer when the source passes the observer is 136 Hz. Second question is you need to calculate the frequency observed by the train engineer traveling on the train, meaning that our observer now is the engineer, and that engineer as an observer moving with the train. So the speed of observer is equal to the speed of train. Am I right? So if the speed of observer same the speed of train, when you substitute, you will get that V over V is equal to 1. So because of that, the frequency that observed by the train engineer is same with the frequency produced from the sound source, which is 150 Hz. Question number 7 is from topic 8, which is physics of matters. Okay, take a look at question number 7a. A 3 meter length of copper wire with a diameter of 0.4 mm is suspended from the ceiling. When a 5 Newton load is suspended from the bottom of the wire, it extends by 0.9 mm. So referring to the question, this is all the information given. Do take note that 3 meter length is referred to the initial length, diameter, the weight, the load is referred to the F, and extend by 0.9 mm is referred to delta L. Okay, to calculate the stress on the wire, we know that the stress is equal to F over A. If you refer to the information, firstly we need to calculate the A, cross-section area of the wire. So A is equal to pi r square, R is equal to D over 2. So D over 2 square is equal to D square over 4. Because of that, when you substitute the D, you will get that the area is 1.26 times 10 power 97 meters square. When you get the A, substitute in the equation of stress, and you will get that the stress on the wire is equal to 3.97 times 10 power 7 Newton per meter square. To calculate the strain energy stored in the wire, you can use directly the equation of strain energy, which is half F delta L. F and delta L is given from the question. You substitute, and then you will get that the strain energy, it is equal to 2.25 times 10 power negative 3 joule. Question number 7b. A steel rod has a length of 0.5 meter and a radius 1.5 centimeter when the temperature is 20 degrees Celsius. Take alpha equal to 11 times 10 power negative 6 per Kelvin, and the Young modulus of the rod is 200 times 10 power 9 Newton per meter square. Alpha is actually the coefficient of linear expansion. So referring to the information given, you need to calculate the change in length on a hot day when the temperature is 50 degrees Celsius. So to calculate the change in length is actually delta L. So our equation for the linear expansion is delta L equal to alpha L naught delta T. You substitute the value given, where the coefficient of linear expansion alpha is 11 times 10 to the power negative 6, L naught is 0.5, and the change in temperature, final minus initial. So our final temperature is 50, our initial temperature is 20. You will get that our change in length is equal to 1.65 times 10 to the power negative 4 meter. Question number 2, you need to calculate the compression force on the rod. So for the compression force, or for the force, we will refer to the equation of Young modulus. Actually, Young modulus is equal to stress over strain. Stress is F over A, and strain is delta L over L naught. So we'll get this formula. And if you refer to the information given, we have no value of A, but we have the radius here. Because of that, you can calculate the cross-section area A, which is equal to 2 pi r, and then substitute the value of A in the equation Y, L naught, and delta L. Delta L as calculated in first question. So you will get that the compression force on the rod is equal to 4.67 times 10 power 4 Newton. Question number 8 is from topic 9, which is kinetic theory of gases and thermodynamics. And for question number 8a, it is from the kinetic theory of gases. Referring to the question, the Roth mean square speed of the helium gas is 1420 meter per second. The pressure of the gas is triple, while the volume and the number of mole of the gas are kept constant. So referring to the question, we know that because of the pressure of the gas is triple, meaning that it is two situations. So I just represent 1 for the first situation and 2 is for the second situation. And to calculate the new Roth mean square speed, firstly take a look at this equation. PV is equal to 1 over 3 nm VRMS square, and also N is equal to N over NA, and equal to M over M. The purpose of this equation is to show that because it is stated that the number of mole are constant. So when the number of mole are constant, the number of molecule N is also constant, and the mass is also constant. After that, take a look at the equation. So because of V, N, MM is constant, we get the relationship between the P, pressure, and the VRMS square, which is it is directly proportional. From that relationship, we can use the ratio concept to calculate the new Roth mean square speed, where it is equal to new Roth mean square speed square is equal to P2. P2 is 3P, P1 is P, and then we substitute the VRMS1, 1420 square. you will get that the new VRMS, the new Root mean square speed, is 2460 meter per second. Question number 2, you need to calculate the new temperature of the gas if the molar mass of the helium gas is 4 gram per mole. Before we do the calculation for the new temperature, we know that the molar mass is given in the gram per mole. So what you need to do, you need to change to the SI unit first because of our R is in the SI unit. So when after you change, you substitute in the equation, you will get the answer for the new temperature, or T2 is equal to 970.97 Kelvin. Question number 8b. Figure shows a 1.5 mole diatomic gas is filled in a 0.8 meter cube container at 321 Kelvin and pressure of 1.45 kilopascal. The gas is isothermally compressed from A to B to the volume of 0.3 meter cube and pressure 3.22 kilopascal. Then the gas expands isobarically to its original volume, which is C. And the final temperature of the gas is 500 Kelvin. So we need to calculate the total work done in the whole process. To calculate the total work done, actually there are two thermodynamic processes here, isothermal compression and also the isobaric expansion. So to calculate the total work done, it is equal to work done in the isothermal process plus with work done in the isobaric process. And for the work done in the isothermal process, the equation is nRT ln V final over V initial. So in this case, V final I just represent by VB because of this is compression, isothermal compression, and V initial is VA. For the isobaric process, PB is the pressure for the isobaric process, and V final minus V initial. For the isobaric, final is VC, initial is VB. And if you refer to the given information, it is a lot. My suggestion that you need to use the correct subscript to list the information so that easier for you to substitute in the equation. So when you substitute, okay, be careful with the part of V final and V initial. Please refer to your figure, and also the pressure. Because of pressure here given 3.22, but don't forget at the y-axis it is a kilopascal unit. So times 10 power of 3 is important. When you calculate, you will get that the work done is equal to negative 2.31 kilojoule. Negative shows that for the whole process, the work done is on the gas. Okay, next we want to calculate the change in internal energy of the gas for the isobaric process. Isobaric is from B to C. So to calculate the change in internal energy, we will refer to the equation of delta U equal to F over 2 nR delta T. And here F is degree of freedom. Because of this is what type of gas? Okay, it is stated it is a diatomic gas. So for the diatomic, degree of freedom is equal to 5. Okay, referring to the equation, just substitute the value. N is 1.5, R is 8.31, and for the delta T, T final tolak T initial. So T final is at point C, the temperature at TC is 500 Kelvin, and T initial is at B. Because of it is an isothermal process, TA is equal to TB. So TB is, temperature at point B is 321 Kelvin. After you substitute and calculate, you will get that the change in internal energy is 5.58 kilojoule, showing that the positive value for change in internal energy, it is the increasing of internal energy in the process. Okay, that's it for the discussion of the solution for Ujian Selaras 2 for this session. So, thank you for listening. I wish you all the best and good luck for your PSPM. Thank you so much.